So today we are solving this question. LeetCode 3130. Find all possible stable binary arrays true. This question is just a continuation of a question we solved yesterday. That is, find all possible binary arrays 1. The problem is similar. Only the constraint is different in this question. Then also I'm reading this question. Let's read this question. You are given three positive integers 0, 1 and limit. A binary array ARR is called stable if the number of occurrences of 0 in ARR is exactly 0, the number of occurrences of 1 in ARR is exactly 1, and each subarray of ARR with a size greater than limit must contain both 0 and 1. I have explained this condition in my previous video. You can refer that. This statement is a little bit difficult to understand. You can refer that video, then the concept will be. Return the total number of stable binary arrays. Since the answer may be very large, return it modulo 10 power 9 plus 7. Now I have explained all the best cases there. We can refer there. I'll just give a recap then also. Okay, let's revise what we did. What I was doing that suppose once given is 3, 0 is given 3, and limit is given 2. That means I can't have three zeros consecutively or three or more than three ones in my array. How I was building this? Suppose I started with 0. I can have 0 and double 0. Okay. Then if I start from here, I can have 1 or 2 1. Then again, suppose I took 2 1s. I can have again 1 0, 2 0. Suppose I took 2 0s. Then I can have 1 1 or 2 1. But this will not be valid as number of ones are 3 and I have already used 2, so I can't have 2 more, so I have to take this one only. And how my final value would look like here? 0, 1, 1, 0, 0, and 1. So I have used 3 zeros and 3 ones, and you can see here that no no two consecutive means two consecutive we have. No subarray whose length is greater than limit, that is subarray of length 3. No subarray of length 3 is there that contains only 0 only. What was the question asking? That each subarray of array with size greater than limit must contain both 0 and 1. So in this array you can see each subarray of length greater than limit has both 0 and 1. So in this way, we were solving, and it was solving recursive. Um, I already told that you should go through this video. This is just a continuation of the above. Here only constraint constructor. Previous video in this one, the constraint was 200. Here the constraint is 1000. So the constraint is vector and the rest of the question is same. Previously we were solving the question in this much time complexity and it was running fine as it was still in our bounds. 200 into 200 into 200. So still fine. 8 into 10 to the power 6. It was okay. But here the constraint is 1000. It will go like 10 to the power 9 here. And this will not work. So we will see what we were doing down there. We will do here the same thing in this much time complexity 0 into 1. Let's see. Previously, what we are doing, we were taking a loop of zeros, then a loop of 1, and inside we were just using two loops. And I will show you that this loop is not necessary. No, not a better way. Let's see. When we were finding this DP array, what we were doing, suppose I had to fill this one DP at I, j and 1. What I was doing, I was taking uh, the sum of dp of I j minus 1 0 plus I j minus 2 0 and till the j minus 1 is greater than limit. I was adding all the values. Now let's see. Suppose I have a j plus plus. Now I have to calculate for this one. So I will add this one. In the similar way, now let's subtract these two. Subtract these two. So what I will get? This one get cancelled. This one will get cancelled. This one will get cancelled. Only this will remain. This will remain. Now, if we rearrange this equation, we will get this formula. This is our formula. Similarly, for 0, we will get this formula. Now, our this inner loop work, that was limit time has boiled down to a constant formula. Okay. These are our base cases. What this base cases define? Suppose I have 1 equals to 3 and 0 equals to 0. In how many ways I can make this array? 1 equals to 3 and 0 equals to 1. No arrangement is there. Only this is the possible array I can make. So this is the basis that if this is 0, I can only make one possible array. Okay. Now, now let's move to the code. I will explain while coding this. It will be clear. First of all, I need to create the BP array. I'm directly solving it in bottom of manner, the tabulation way, because I already explained the memoization part in previous video. You can refer that. And I will suggest to you all to solve solve this in memoization way by yourself. That will also work. I will provide the code later on. You can refer that, but you should solve by yourself. So I have created the BP array. Now let's write the base cases. Why this is 0, comma limits minimum, and why it is 1, comma limits minimum. I have already explained all those in previous video. That only I said that the concepts are similar only. Now I will write the transitions here. Transitions are better to say the DP logic. J equals to 1, j less than equals to 1, j plus plus. If I equals to 0 or j equals to 0. These are our base cases, so we don't need to calculate them. Base cases only already known. I will continue. Okay. So dpf I at j 0 will be dpf I minus 1 j 0 plus dp of I minus 1 j 1 mod. Oh, I need to define mod also here. Then to mod equals to 1 to minus 7. Now, if I minus 1 is greater than or equal to limit, what I will do, I will get dp of I j 0 equals to dp of I j 0 minus dp of I minus 1 minus limit j 0 plus mod 1. I will have to do the same for dp of 1 I comma j minus 1 I comma j minus 1 if j minus 1 is greater than limit if j minus 1 minus 2 comma 0. And at last we will return dp of 0 comma 1 comma 0 plus dp of 0 comma 1 dp 1 at 1 and mod of that's undeclared of dp. Here so it should run. Yes.